Okay. What is the derivative and what is the actually the basic concept of integration? Okay. So, for example, if one mass is moving from moving from A to move toward start moving from A to point B. Okay. It has started the motion from A and moved toward the B. Okay. Position vector of A with respect to origin O, that is representing by R. Okay. If I say that this is it is at time T1 and then it moved toward the point B or T2. Okay. When it is moving from A to B, it will choose this path. Okay. It is moving along because when we move along any path, that is not necessarily that path will be a straight. It may be any type of path, that may be a curve or a, okay. So, let's suppose this is the path, okay. It choose this path, okay. But in mathematics, we have only one way to calculate the difference, the length of this path is by joining this and that will be defined as delta R. You may say that R2 or whatever, okay. This is the delta R. But we are interested to measure the length of path. But we are interested to measure the length of path. What is that? That is, this length is L. Okay. We are interested to measure the L. Okay. Not L is not vector. Okay. We are interested to measure the length of L, this path, this black line. But according to vector or mathematics, we can only measure this delta R. Okay. So, this unfortunately, so what is, but RT2 according to head and tail rule, according to head to tail rule, RT2 will be equal to RT1 plus delta R. Okay. This implies that delta R will be equal to RT2 minus RT1. Yes? Okay, but this is length of this delta R, not length of this L. Okay, this is not the length of L. But we are interested because whenever we cover any distance, that will be along the path. That will be and that path will be not necessarily that will be a straight. They will be like this curve, any type of curve. So, but we have to measure this, but we can only, unfortunately, we can find only the delta R. But we have to calculate, if you are interested to find the velocity, work, energy, whatever, any physical quantity, if you are interested to measure, then we have to measure this, because all energy is utilizing along this path, not along the displacement. Even if you do some work, okay, the distance covered under the action of the force, that means it depends upon your path. If that is not a conservative, if the conservative force, then that will be depend upon the displacement. But if it is not a conservative, then that will be depend upon the path. यही वजह है कि आप when you come to the university, आपका petrol, अगर if you choose the long path, the petrol will be consumed more if you use the shortest path. Okay, so it means the consumption of energy or work will be depend upon your length of the path. Okay, if the length of the path is large, then you will consume more energy. But if the length of the path is small, then you use the less energy. Even the displacement is the same. So actually, you are interested to this L. This L is not a vector, sorry, but not a delta R. But unfortunately, you may only measure the delta R. So what is the procedure? But fortunately, we have a method in a method. We will divide this path into the small patches. Okay. Yes, you mean if we divide it into the small patches, number of small patches. Okay. There are different patches. Okay. For example, if I say that according to these patches, this will be delta R1, this will be a delta R2, this will be a delta R3, and this will be a delta Rn. Okay. And associated length are, yes, that will be a delta L1, this will be a delta L2, this will be a delta L3, and this will be a delta Ln. Okay. Okay. Now problem is that this is a vector and this is, even then R delta R for, but so for this purpose, we will divide it into small patches. Okay, we will divide it into these small patches, and that will be patches will be a what will be the that patches? That will be a delta R1. That will be delta R that will be not equal to delta L. Even then, that will be a vector. Okay, delta R2 will not equal to delta L2. Delta R3 will not equal to L3, and so on. And or you may say that delta Ri, because I is different, because here the length of the path is different, this length is different, this length is different, and here you may say that this length is different than this, and delta Ri will be not equal to delta L, where I is equal to 1, 2, 3 up till n. Along this, delta Ri will be not equal to delta Rj, or I not equal to j. Mean if you consider 1 or 3, the length may be different. Mean for different r's, r will be not same, not identical. Okay. So if patches are infinitesimal small, as mean if delta Ri approach to 0, mean this length become so small, then all these r's become equal. Because that will become a small. So these all R will be like this mean LT mean limit. Okay. Delta R approach to 0. Delta R. Now delta Ri will be replaced with the delta I, because that are the same. And this will become dl. and because this will be like a delta L vector, and this is a, and this small patches, because it become, all curved line become a straight line, and this small patches will become a infinitesimal small, and that will be become a straight line, and that will be treated as a displacement. So this displacement will be equal to this displacement, and this will make a tangent. So this will be dl or dr. So in this case delta r will become, tangent mean दो 2 points will be, यानी ये इसके along. So this will, this अगर मैं इसको mean actually this is not this length, actually this is, okay, I mean this is of infinitesimal small, okay, and if I zoom it, I am zooming, that is not okay, I mean if I zoom, okay, this will be delta r, sorry, this will be a dl, and this will be a dr. ये मैंने इस लेंथ को, ये जो इतनी छोटी सी है, इसको इतना जूम करके ताकि पता चले कि असल हो क्या रहा है, कि ये दिस विल बी actually this will become a straight line that is that has an infinitesimal small length, and for this dl will be equal to delta r, and all delta r will be identical in this case, because that are infinitesimal small. That's why this will be replaced with this, and that will be defined as a, or this is defined as a, yes, derivative. Yes, सारे r's जो हैं, that will become a infinity, they become identical, all r will be a same. Here r are different, you may say that r are different, but here r is, why this I have seen dri1 will be equal to drij, and this, या आप कह सकते हो 1 2 3, आप अगर ij मुश्किल लग रहा है 1 2 dr3, यानी all will be same, and that will be equal to dr. That's why, because all are the same, one dr1 dr2 dr3 all are the same, so we may replace it. Why I have replaced it? Because r1 r2 r3 are the same, so that will be replaced with the delta r. मीन अब हमें इंडिसेस की जरूरत नहीं है, इंडिसेस की तब जरूरत होती है जब r1 is a different than r2 r3 r4, but when that is a infinitesimal small, in that case delta r1 will be equal to delta r2 delta r3, and that will be sum, and that will be a same. Got it? Okay, so all this will be a dr. Okay, now you have a different drs. Okay, हमारे पास, okay, ये देखना स्पेस इधर है, ये लाइन नहीं नजर आ रही, अच्छा इधर से कर ले, ये तो सारा आ रहा है ना. ओके ओके, okay, what is the delta? So L will be जो total length है, what is the total length? It is the sum of all these patches, sum of patches I equal to 1. Number of patches will be, if the patches is infinitesimal small, number of patches will be a approach to 0. L will be equal to, L is a scalar quantity, but it is sum of that. Okay. Limit, what I have applied the limit delta Ri approach to 0, delta Ri, yes, okay. So L will be sum, total L will be sum of this infinitesimal small, n is equal to infinity, because why? Because why? Yes, because, okay, n equal to infinity, because इसको फिर हम ऐसे लिख लेते हैं, because why? N is infinity because delta R approach to 0, क्योंकि patches जो है delta R approach to 0, because patches is so small, so number of patches will be increased, that will be infinity. Okay, so that's why here I use the infinity. Yeah, you may say that n equal to infinity. That's why I have used this. Okay. And this delta, and this may be right as I equal to 1 to infinity, limit delta R I approach to 0, delta Ri. Yes, we may write in this way. Yes, okay. Limit को इधर ले गया, sum को बाहर ले गया. ठीक है, okay, you may write it, and according to this formula, yes, according to this formula, this is a I must say that delta R approach to 0, and this is delta R. Now I will be replaced with the, as I have done it in this way. Okay. And this is I equal to 1 to infinity. And what is this? This is dr. This is a, what is this? This is a dr. And this sum, which is continuously summing an infinitesimal small element, this sum is defined as integration. And this sum, I equal to 1, which is applying the differentiation. The sum which is applying on a differentiation is defined as a integration or integral. Yes, you are right. And what is the boundary condition of this integration? You are starting motion from A to B. So that means A to B, okay, dr. Okay. This line is defined as this is integral from A to B. This is defined as integral from A to B, and this will be defined as, yes, what is this? Differentiation of R. This is the derivative of R. So that is the actually concept of derivative and integration. Yes? Okay. This continuous sum for continuous functions mean that, that there is a not break. This is like a continuous function. There is a no देयर इज नो कट और अनडिफाइंड रीजन, ठीक है, इट मस्ट बी अ फंक्शन, आप इस सेंस में कह सकते हैं, जो भी रेंज डिफाइन कर रहे हैं उसमें वो फंक्शन होता है, तो उसको सम करते हैं, तो कंटिन्यूस सम ऑफ स्मॉल पैचेस इज डिफाइंड एज अ इंटीग्रेशन. So that's why this sum will be replaced with the integration, और this delta r जो approach हो रहा है, ये मैंने पिछली दफा भी बताया था, that is defined as the derivative. So that is difference between this integration and derivative. So if I ask the question, what is the difference between the integration and differentiation? If we divided it into the small patches, that will be infinitesimal small patches, okay, continuous infinitesimal small patches. The change in infinitesimal small patches, ठीक है, जो भी फंक्शन होगा उसके, ये आर यहां फंक्शन के तौर पे ट्रीट हो रहा है, दैट विल बी डिफाइंड एज अ डेरिवेटिव. एंड इन्फिनिटी द सम ऑफ दैट स्मॉल पैचेस जो इन्फिनिटिजिमल स्मॉल है, यानी कंटिन्यूस सम है और इन्फिनाइट को टच कर रहे हैं, हियर दैट इज the range is infinite, मतलब आपका जो last point है वो infinity, मतलब if you divide it into the slice into the infinite number of patches, then this sum will be defined as the integration. Yes, that's why बाज का लोग इसको इंटीग्रेशन को एंटी डेरिवेटिव भी कहते हैं, मतलब दैट इज नॉट अ ट्रू टर्म, बट इसी वजह से कि छोटे पैचेज जो हैं वो डेरिवेटिव और उनका सम इंटीग्रेशन मीन दे आर एंटी ऑफ ईच अदर. मतलब अगर स्मॉल पीसेज में डिवाइड करते हो तो डेरिवेटिव है, और अगर लार्ज बना देते हो उसे तो इंटीग्रेशन है. सो इंटीग्रेशन इज डिफरेंट. मिसाल के तौर पे आपके कोई भी काम करना चाह रहे हो, जो चीज़ कंटिन्यूसली चेंज हो रही है, आप उसको सारी को तो कवर नहीं कर सकते, तो आप क्या करोगे, आप उसका छोटा सा सैंपल लोगे, और इंटीग्रेशन के फार्मूले हम यहाँ ड्राइव भी करेंगे और सीखेंगे भी, तो इंटीग्रेशन अप्लाई करेंगे तो वी विल गेट एंटायर इंफॉर्मेशन अबाउट दैट सिस्टम. दैट्स द बेनिफिट ऑफ द इंटीग्रेशन. सो दैट इज द डिफरेंस बिटवीन द डेरिवेटिव एंड if we change this r with the replace with the mean, r is a function of t, here I use the r is changing with the time, but f may be any type of function. R matlab if I replace this function, I may say that may I erase it? अच्छा, in actually you are a computer students. In computer has no ability to slice it into the infinite patches. There may be some discrete number of patches. But this definition we will use in the computer, and we will sum. हम इंटीग्रेशन कंप्यूटर को कैसे सिखाते हैं, हम क्योंकि हमने अब द न्यू पीरियड इज अबाउट कि हम मशीन लर्निंग का दौर है. वी हैव टू टीच द कंप्यूटर्स और मशीन कि हाउ यू हैव टू परफॉर्म देयर ड्यूटीज. ओके, सो एनालिटिक सॉल्यूशंस के लिए वी यूज दीज डेफिनेशन इन कंप्यूटर टू. ओके, क्या हमने डेरिवेटिव मीन व्हाट इज दैट इज द पैचेस, जितना स्टेप हम उसका छोटा कर सकते हैं. आपके पास जितना बड़ा सुपर कंप्यूटर है, जितना हाई परफॉर्मेंस कंप्यूटर है, आप उसको उतने स्मॉल पैचेस में डिवाइड कर सकते हो. ओके, सो इट्स मीन कि हैवी कैलकुलेशंस के लिए आपको यू नीड अ हैवी सुपर कंप्यूटर. ओके, so as I have already explained, dr which was a function of t, okay, this will be equal to rt plus delta t minus, limit delta t approach to 0, rt plus delta t minus rt, that will be defined as a change in r, and similarly delta t will be, dt will be equal to, yes, because it is changing with respect to time, you may say that limit delta t approach to 0, or you may say that t2 approach to t1. Okay, delta t delta mean two different points, difference of the two different points. So that will be the delta t, okay. Or you may say that dr over dt, what is that? That is, yes, limit delta t approach to 0 or t plus delta t minus RT divided by delta t. Okay, the change of R with respect to time. Okay. Yes, infinitesimal small change. Yes, you are right. मतलब यही मेरा कहने का मतलब है, ठीक है. Okay, you may say that t approach to t1, if I write it in the form of this is t2 t1. You may also write it into this form. Okay. If I replace R with the if I replace R with the or t replaced with the f alpha. I mean, alpha is any function that may be a x, that may be y, z. If function of x, if function of theta, if function of whatever that thing, x, y, z, whatever. So what will be the derivative? If I replace df alpha over d alpha, alpha may be a t, x, y, z, mean derivative of, and that represent the f prime, okay, derivative is actually representing by the slash, okay, that will be equal to limit okay, so that is the definition of proper definition of the derivative. Now I think I expected you are the concept of derivative and integration must be very clear to you. Yes. And this is not x, I have taken the alpha. Alpha may be a x, y, z, t, theta, जैसे sin theta. F may be a sin theta, ठीक है? तो alpha may be a theta. Derivative of sin theta with respect to theta, what will be? वो हम सारा calculate करेंगे. हाँ, ये भी लिख सकते हैं, ये भी लिख सकते हैं. There are two notation for derivative. ज्यादातर हम ये यूज करते हैं, असल में बाद में मैं आपको इंट्रोड्यूस कराऊंगा टाइम के रिस्पेक्ट के लिए डॉट का डेरिवेटिव, लेकिन आप अभी कंफ्यूज ना हो तो इस वजह से मैंने इंट्रोड्यूस नहीं कराया. अगर टाइम के अलावा कोई हो तो उसके लिए हम प्राइम यूज करते हैं, ठीक है. तो वैसे ये डेफिनेशन प्रॉपरली हमें बताती है किसके रिस्पेक्ट है, और ये इसका मतलब है कि जो इस वेरिएबल पे भी डिपेंड कर रहा है उसका, मतलब दीज बोथ आर द नोटेशन, डिफरेंट नोटेशन ऑफ द डेरिवेटिव. ओके, गॉट इट. हियर प्राइम मीन the derivative is with respect to any variable. Actually आगे मैं पढ़ाऊंगा, अभी मैं आपको नहीं बताना चाह रहा था. Maybe some student may be confused with this कि टाइम के लिए एक स्पेशल हमने निशान रखा हुआ उसका, उसमें प्राइम की जगह हम डॉट का लफ्ज यूज करते हैं, ठीक है. सो बट यानी यहाँ हमने और डॉट यूज करते हैं अगर उसके लिए प्राइम की, बट आपके लिए अभी वो सोचना जरूरी नहीं है, आपके लिए इतना ही काफी है. दैट इज एनफ. ओके.